All right. Unit 7, Lesson 10, Rewriting Quadratic Equations in Factored Form, Part 4. Let's transform more complicated quadratic expressions into factored form. We're going to look at a little more advanced problems. Each row in each table has a pair of equivalent expressions. We need to complete the table. If you get stuck, try drawing a diagram. So this is a skill that you have probably mastered at this point. Some of you are going to be more comfortable using distributive property, and others will be more comfortable. Let's start over. Some of you are going to be more comfortable using distributive property, and others will be more comfortable using the box method or the area model. All right, so go ahead, use distributive property, multiply these three quadratic expressions in factored form to get the standard form. Go ahead, hit pause, take a moment, try them, and then hit play. All right, so you should have already worked these out on your own. So we're going to get 3x squared plus 12x plus 1x. So 12 plus 1 is 13x plus 4. All right, that's what the first one gave. All right, let's try this one. Here we have 3x squared. Let's use a different color. 3x squared. Here we have 6x. Here we have 2x. So I'm adding the 6x and the 2x together. 6x plus 2x. And there I get 8x. All right, plus 8x. And then 2 times 2 is 4. Great. Okay, the last one, and you've already done this, so I'm going relatively quickly. 3x squared plus 3x plus 4x. 3x plus 4x. We add those together and we get 7x plus 4. I want you to take a minute and notice what's in common here. If you notice, all of the squared terms, all the quadratic terms are 3x squared. And all of the constant terms are 4. But our linear terms in the middle are all a little bit different. So that's an important fact here. Notice 1 times 4 gives me 4, right? All of these second terms multiply to give 4. And all the first terms multiply to give 3x squared. All right, so problem number 2, you are going to go backwards. So you are given the standard form, and now you're going to work backwards to get the factored form. And ask yourself, what multiplied together to get that? And it's a little more complicated than just what times what equals 4 and what times what equals 5x squared. Now you have the puzzle of figuring out what combination would get you to 21. Right? Because if we look back in the previous example, all of these had numbers that multiplied to 4 and numbers that multiplied to 3x squared. So that 3x squared and that 4 were the same, right? But we've got to figure out which combination, which special combination will get us the right middle term. Okay, so I want you to take a minute. You have a couple strategies you could use. Maybe guess and check is one option. Another option is you could use this area model and think about where 5x squared goes here, 4 goes here, and these two need to add up to give you 21x. All right, so take a minute, try this, and then hit play again. All right, so we know there's really only one way to get 5x, and that's 5x times x. So we're going to put a 5x times x. And so 5x times x gave me 5x squared. All right, now what times what equals 4? Well, we have a couple options, right? As we saw in the previous one, it's either 1 and 4 or 2 and 2. And not only is it those options, it could be 1 and a 4, or it could be a 4 and a 1. And those are actually going to be different because we've got this 5 here. So if I do it this way, let's try 4 times x is 4x, and 1 times 5 is 5x. If I add those together, am I going to get 21? No, I'm not. So we're going to go back up, back up, back up. Let's try again. What if I put the 4 here and the 1 there? Let's try it. So 1 times x is 1x. 5 times 4, is 20x. Now when I add them together, will I get 21? Yes, I will. All right. So this inside, that adds up and gives me my standard form. But what I really want is this, right? The length times the width. I want this times that. Those are my two factors. One factor is 5x plus 1. And the other factor is x plus 4. All right, so we could just double check real quick. 5x squared, good. 5 times 4, 20, plus 1, 21x, and 1 times 4 is 4. So we are good. All right, it's always a good idea to double check. All right, there are 2 more for you to try. So I want you to try both of those. Take a minute, try the second and third equation in that box. All right, go ahead and hit pause, and then we'll go over them so you can check your work. All right. You should have already tried this. I really, really, really want to emphasize the importance of you trying it on your own before you watch this, because that's where the learning happens. It's okay if you make a mistake. That's what we're here to make mistakes and learn from them, right? Okay, so if we use this area model, this is what we're looking at. I know that 3x squared is only going to happen by making 3x times x. All right, and I also know that to get 12, there's a couple options. I could, like, what times what equals 12? That's what I'm thinking about. 1 times 12, or 2 times 6, or 3 times 4. So we've got quite a number of options. I like to start with the numbers that are closest together and then work my way back from there. Unless they're like huge numbers, then I might try this one. All right, so I'm going to try 3 and 4 first. All right, so if I try those, 3 times x is 3x, and 4 times 3 is 12x. Oh my goodness. On the first try, it looks like I got something that will add up to 15. That was pure luck, right? If I had tried it the other way and started with 4 and 3, would it have worked out? That would be 4x, and that would be 9x, and 4 and 9 do not equal 15. Okay, so just to emphasize that the placement matters, right? So I just happened to get lucky and get them in the right place on the first try. All right, so here are my factors. 3x plus 3 and x plus 4. All right, the last one looks like this. All right, and you have already tried it. If you haven't tried it yet, now's a good time to pause, because I don't want to take away your learning. All right, I don't want to steal that from you. Okay, hit pause. You're worth it. All right, what times what? Uh-oh, wait a second. Now, there's a couple different ways to get 6x. In order to get 6x, I could go 1 times 6 or 2 times 3. So this may not be the result. This might take a little more thinking. Okay, I'm going to try 1 and 6 and see what happens. So how do I get 10? Well, there's a couple options. 1 and 10, right? 2 and 5. So I like to start in the middle. So I'm going to start with 2 and 5 and see what happens. Let's change colors. All right, let's try 2 and 5. 2 times 6, 12x. X times 5, 5x. 5, 6, 7. That's only 17. So that's not going to work. Now, I'm using guess and check. I want to make sure I go through all my options. Since I had 2 on top and 5 on the side. I'm going to switch, try 5 here and 2 there. 5 times 6 is 30. And 2. 30 and 2, that's way too much. That's not going to give me 19. Okay. So maybe it's 1 and 10. So we've got lots of different guess and checks that we could try. All right. So if I try 1 and 10, 10 and 6 is not going to work. And if I put the 10 here, it'd be 60 and 1. So it's too big. So it seems that both of these are not going to work. Well, that was using 1 and 6. So maybe 1 and 6 isn't right. Maybe we needed a 2 and a 3. So let's try 2 times 3. All right, because 2x times 3x is 6x squared. And now let's go back to 2 and 5. So now let's try these two. If I go 2 here and 5 there, 2 times 3 is 6x, and 5 times 2 is 10x. Nope, that doesn't work. All right, let's try to switch those and see if that works. If I put 5 times 2, all right, 5 times 3 is 15x, and 2 times 2 is 4. Whew, we found it. That took a lot of trial and error. Okay, but we found it. So it looks like our factors are right here. 2x plus 5 and 3x plus 2. So I needed some perseverance on that one. Again, we want to double check to make sure it works out. 2 times 3 is 6x squared. 2x times 2 is 4x. 5 times 3x is 15x. So we're good with that 19. And 5 times 2 is 10. So we're good. All right, thanks for watching.